Welcome to Enots Engineering, I'm Alan. In today's video we finish off the tool post drill spindle. This is part 2 of a 2-part video. If you've missed part 1, the address is up here. In this video, this is the finished item. We make the tool post bar, which is this, the backing plate. We fit the 2 linear bearings to the bar. We make the outer spindle, which has 2 needle bearings inside and 2 oil seals. We also make and fit the collar at the end that holds everything together. And at the end of the video we'll test out the drill spindle. So let's go into the workshop to see how we did it. So I've just roughed that out to square, no particular size, just as long as it fits in there and leaves clearance. I've fitted the square bar to the aluminium with 1 cap head and fitted it into the tool post. Now I'm just setting the bar parallel to the tool post using the dial indicator, then I'll drill and tap for the 2nd cap head position. Zeroed it there and just checked that the bar is running parallel. I've clamped the bar in position and now I'm drilling through the steel bar using the 5mm hole in the aluminium as a guide. Here's the finished body with the 2 20mm bearing blocks bolted to the aluminium plate and the steel bar for the tool post fitted. I've put my 4-jaw chuck on, held the bar, this 23mm bar in the chuck, and I've clocked it up this end, 0. Each division from 0 to 10 is 1 thou, so these are tenths of a thou. So this is running through here just over 1 thou, and the reason why I've clocked it up this end is because I want to face it off, put a centre in, and if I'd have clocked it up down this end, you'll see this is running out 10, 12 thou. Okay, I've turned the bar around in the chuck, plot this end up to 1 thou. As I said before, if I move this down, you'll see here it's running out 10, 13 thou. So what I'm going to do is centre drill this, face it off again, and then I'll put the bar between centres. Okay, I've put the revolving centre in the tailstock, driving dog, and the plate, the driving plate. And let's check the run out. So if I bring it into 0 on this end, 3 thou. In the middle, 2 thou. Five thou. About 3 thou up. Now that's ready for polishing because I need a nice smooth finish. There's a guide bar that was commercially made, 786. So I've got a bit of polishing. It should get rid of any of these lines. Turn it round. Take off the carrier. I've put a piece of tin so I don't damage the surface too much. I want to just rough this down. 2 reasons. First one is this should fit through the headstock spindle, but this won't. So if I leave that size, I won't get it any deeper into the chuck than here. So if I take this down to this size, this will go right through so I can grip in the middle of the bar. I've polished that up now and I've fitted it on the bearings, and it's a bit tight on the bearings. You might be able to see lines along the bar where the bearings have actually rubbed. But what I don't want to do is take it too small. As I use this, because this is soft, the bearings will wear lines along here and that helps stopping it from rotating. If I was buying some material for this, I think I'd buy the 20mm guide rail bar, which is a case hardened bar. You can still machine the inside and you wouldn't have to turn all the outside down because it is made to fit the bearings. So if you look at the bearing blocks, you can see I have rows of bearings, and the bearings inside these blocks move along the grooves in the go round the back, come back down and do like a circle along the bearing. So if you put side load on these by rotating the shaft, it makes the groove wider, and then these bearings start to come loose and fall out. So at the moment we've got the 2 linear bearings fitted to the aluminium block. On this side we've got the tool post bar, which is bolted from the other side, 2 cap heads. These 4 cap heads on this side have been recessed. On this side they don't need to be recessed because this is where your tool post will be here. We've also made the chuck holder on a 12mm shaft with a triangle machine on the end so the chuck jaws will grip. We've made the bar, the guide bar, which will go in the bearings. This will move backwards and forwards. The next job is to fit some bearings and seals to this. These are the bearings I've purchased. SKF HK 1210. They're a small needle roller bearing, and I've also got two seals to go with those. The seals are 12mm by 18 for the shaft, 12mm bore which will go on the shaft, and 18mm diameter, and the bearings are 12mm bore by 16mm diameter. So the next job is to drill in the end of the bar to hold the seal and the bearings, so it'll be 2 bores in each end, and then I'll drill a hole straight through the centre. This is how I set the depth of the boring bar for the hole I want to produce for the bearing and the seal. And the bearing's 10mm wide, the seal's 5mm, that's 15, and I want to go in about 2.5mm more, so that's 17.5mm I want to go deep. So I come up to the face of the bar, just touch it, lock the saddle, back this off 17.5mm, so that's 2.5, 5, 10, 15, and one turn, that's 17.5. Unlock the saddle, bring the tool in until it touches the face, and set here my dial indicator to 0 on the travel of the saddle. Turn it off, wind this back 17.5, 1, 5, 10, 15, 17.5. If I wind it to the back and move it into 0 on the dial indicator, it is around about 17.5mm. Bore gauge is saying I've got about half a thou to come out of that bore. Take the highest reading, it's about half a thou. I'll put a lead in on that. That will go in. Put the bearing in the top. Now I'm just tapping this oil seal in. the seal, and just behind that the bearing. I'll do the same on the other end. There's the top bearing. And I've made it so the seal is just below the edge, so that when the chuck goes in it doesn't hit the seal and damage the seal. Now another little tip, when you're trying to drill in the centre of something that's round, if you put a rule on the top and just bring your squash it between the parts, you can then centre it. If it's off centre you'll get a gap under the rule. I'm just moving it along a bit. That looks, you get an equal gap each side. That looks centre. Let's see if it is. Before I assemble it, I'm just putting some grease in the bearings each end. I've put a flat on the spindle there, so I'll assemble this pushing the rod through this end. Just wipe the excess grease that's come out. And the collar we made goes on there. That's the collar, just a 6mm grub screw goes onto the shaft. Just lock it up on the end. But leave a little play between the inside and outside so it can turn. That's okay. So the collar's there, so when you push with your drill on this side it'll only go up to the rail, and then any longitudinal movement will be taken up by the rail and not push your spindle out of the centre. On the other end you've got your chuck, so that's ready to try. To square it up using a square, put the square on the chuck, slacken the tool post, and using the top of the bearings swivel it around till it's square and lock the tool post. First fit your drill on the end, lock it on the flats, and that should support itself. You need just a small amount of play between the inner spindle and the outer spindle on this. Then you can move this in and out easy enough by pushing your drill in and out. Push your drill up to the part. Change your drill. See how the outer bar guides it backwards and forwards, and the inner bar with the chuck on just rotates. You can use obviously in reverse. So if you're tapping a hole, the tap will pull it in itself. And now I've set that on centre. And at the same time you can zero your dial on your cross slide. So if you wanted to drill a hole at a 50mm radius, you can turn the cross slide out 50mm and drill the hole. Oh well, that's it for today, and I hope to see you next time on Enots Engineering.